Good day, everyone. Today's video is going to focus on CrimeStat 4, how to bring in a point file, your primary file, set up your reference and measurement parameters, and we'll get into our spatial description. Primarily, I want to run a standard deviational ellipse with a mean center, pull that back into ArcGIS and just show you what it comes up as, how you can save some of this, and walk through some of the first steps. With that, like I said, CrimeStat does take some user familiarity with GIS. So I'm going to be going back and forth from ArcGIS Pro to CrimeStat to pull in some of this information. To start off, I already did go ahead and download. You can see here's version 4.0 distribution, but it's all the chapter material for the book. Today's video is going to primarily focus on what's in chapter 2. We're not going to get into all the spatial descriptive attributes or tools that it has in it. Chapter 2 and 3 really get into those, describing the data, how to enter the data, some of the nice parameters that you should be familiar with. So I recommend go ahead and become familiar with those. If you have questions, feel free to reach out. Some of this I'm more familiar with than others. With that, it's a learning process. That's why I'm making these videos. It's a refresher for myself, but hopefully if anyone out there is as familiar, more familiar, and I make a mistake, please let me know. Start off with, though, we need to input a primary file. This is going to be our point file because we just want to look at a crime data here. So with that, I have GIS open. And right now I have our violence in Little Rock from 1999 through 2022 point level data here. Some of the main parameters that you need to be familiar with or to make sure your data set has in it, and so we can put it in CrimeStat, is we need an X value and a Y value. So we need to make sure our attribute table has that. And we also need to be familiar with the coordinate system. So is it projected or is it in your geographic WGS, the common one with that? So with that, if you're oftentimes working in GIS and doing some type of distance analysis, you're probably already working with projected data itself. My Little Rock data are projected. I know that because that's just how I input the data when I geocode it. But if you're familiar with it, if you don't know, if you're in ArcGIS, you can go to Properties, come down to your source, your spatial reference, and it will show you your projected coordinate system. You can go through, if you're in QGIS or ArcGIS, you can transform your data or you can project it from WGS to a state plane coordinate system. I'm just familiar with Arkansas since I do a lot of work in Little Rock. This one is what I oftentimes have it set to when I download it and geocode it. There's plenty of videos out there on how to project data. If you have any questions, feel free to reach out. But it is important to understand you need to know if you're working with projected data or not. With that though, we're in pretty good shape. If I open up this attribute table to it, keep in mind if you've watched some of my other videos, this is actually some historical data that a student's been working with. It had an offset when it was geocoded, so we had to find the nearest XY coordinates that put it on a street segment, and then we had to display that XY here. Say you had a data set that didn't have X or Y data in it, we can actually add a couple fields. I'm going to put them at the end, and it's just going to be X chord, Y chord. And if you're looking at this one's not as cleaned up as I usually like, but all these are just counts of crimes itself. So nothing too crazy there. With that though, we're going to add a field. It's going to be X chord, and I want this as a double. And then I also want to add another one that's just going to be Y chord. Oops, take off that one. It's going to be a double as well. Going to save this. And now in my attribute table at the end, we're going to have two new variables or columns here that I need to assign. And so with that, I'm just going to right click, and then this one's going to be a geometry one. You can see here, it's going to probably pick up that I want the X coordinate for this. So I just need to specify that here. It's a point, so I want that here. Since I already have it open, I can select and put in the second Y chord that I made here. Specify I want this to be the Y coordinate itself. The format, same as the input. This is where it does matter. Make sure you have the correct coordinate system. I want it the same as my map. I already know it's set to my projected one. So you can see here it's going to be in my feet. Click OK. Let it run, and it's just going to update that with my X and Y coordinates for this data. So you can see I just have under 45,000 incidents over the year. I want to pull this in. I want to find the standard deviational ellipse that captures truly the 68% of crime incidents, violence here. It's assault and homicide over these years. And I can find the mean center. So it's truly the mean center of all of these XY coordinates, where that point is. Keep in mind, like general statistics itself when we're looking at the numbers. Same applies when we look at the standard deviational ellipse and mean center. You just interpret it from a spatial perspective. So when we generate that, we'll go over it again, but it's a nice way to think about the data. All right, since I have the XY coordinates in here, I'm just going to export this as a new field. It's already saving into, well, it's not where I wanted it to save. It's in my example data for my CrimeStat folder. So it's my historic, and I'm just going to put XY at the end, so I know this is the file that I want to work with. Going to click save here and click OK. It's going to generate that new layer for me. It's going to auto add it to my table of contents. I'm just going to remove it. Not a huge deal for us right now. But now we can actually come back into CrimeStat. So I have this pulled up, and I want to select a file, and I'm just going to direct it to my DBase file. If you're not familiar with DBase, think about it as your attribute table that's located within your point layer. You can also open this DBase file in Excel. It reads it the same way. You can also change this if you have a point layer. All of this is in there, so you have the ability to change that. I'm going to direct it to the folder that I've been working in. So this is a CrimeStat folder, example data, and I want my XY. Click open, click OK. And now that it's directing all of the other file types to this, I want to specify my X column is my, as you can see here, X chord and Y chord. Since I brought this in as a shapefile, the X and Y at the start would be the same here. If you only had it as a DBase file, or think about it as like a spreadsheet in that sense, you would want to specify the X and Y chord. We don't have to worry about the intensity, the weight, or time. We're not messing with those right now. We'll come back to the time units in the future. I would say pay attention to how you need to have the time units in a file before bringing it in CrimeStat. It is different in terms of how we expect to bring it in a date format. With that, the type of coordinate system, it is projected, so we want to keep it or check that box or that circle. We're in feet, so we're good to go here. With that, we have our point data. We're specifying our X and Y coordinates. With that, we don't need a secondary file, but we do have a reference file that we need to make sense of. And this is where it's the tricky part. And I remember years ago when I was first learning this, of how do I find the X and Y coordinates for the lower left and upper right. So essentially think about creating a grid over your study area. For us, it's Little Rock. It could be a county, it could be another city, it could be a smaller census tract. Whatever you're trying to work with, you need to know the lower left and upper right, so you're truly putting a fishnet or a grid over that. I have a video that's on ArcGIS specifically on how to make a fishnet. I cheat in a sense of grabbing this information relatively quickly in ArcGIS Pro, and I'll walk you through how I get these coordinates, and then we'll get into measurement parameters next. With that though, so I know I need my lower left, upper right, X and Y for this. Now when you're in ArcGIS, and if we just turn off our crime layer, it's asking for your boundaries. So I need to know my lower left and upper right. What would be the coordinates that encompasses all of Little Rock? If you're familiar with ArcGIS, you know that when you run kernel density, it does the same part, but the key part to that is you have to specify your processing extent to your boundary file, not your point file. So to do that, I have the crime analysis toolbar already installed. If not, it would be the same density option in here. You're just running kernel density. You would put it all in here. When I say I cheat the system, I come over to processing extent. I'm changing this to my boundary file here of Little Rock. And now I have my lower left X and that would be my lower X here. And this would be the Y. And then the upper right would be these X and Y's here. So I have this information. Now I just have to copy and paste it over into CrimeStat, which not shockingly can be a pain. So I'm going to just pull this so I have them side by side real quick. So my lower left would be this one here. And the Y would be the one starting with 2. And I'm just doing the same now for the right. I'm just copying and pasting these across from each other. So these are the coordinates. Did I grab all of that? Yeah. For the grid itself to run. And I show this now because we'll have to use this time and time again in CrimeStat. So just get in the habit of this. If you want to save these to a separate document so you have them, you don't have to go through this GIS part each time, but it is handy to know where these come from. You can get into cell specification if you want to read on that in the chapter. For now, we're okay. The next part is our measurement parameters, and this relates back to our study area itself. So our area truly is Little Rock, so we want to have the area of that. And the length of the street network, depending on the type of analysis you want to do, that is just as important too. So with that, I'm going to show you how to import these. In the future, we'll use these in different capacities. Street network, I don't do as much with in terms of network analysis. There's some great research out there on it. I just haven't gotten into it myself personally. But with that, let's identify our square miles for the area of Little Rock. So we have a boundary file here. Let's open the attribute table and see what it has in it. So we have some good information in it. I downloaded this from the Arkansas GIS office itself. So we see that we have some population parameters here from, oh, they even have the 2020, which is nice. We do also have our square miles here. In case you did not have this, similar to how we added the XY coordinates, if you needed to calculate what this area of the polygon is, our boundary of Little Rock here, we're going to go to add, and we're going to just do area, and we're going to make this a double. Keep in mind, double brings in the decimal places, so we want to add that in. We're going to save, and again, this is going to add a column at the end for area, and we want to calculate this geometry too. It's pretty good since I labeled it area, and it's a polygon. It knows I probably want to have an area with it. So we have area. And here's when we have to specify what kind of units do we want. We want square miles. There we go. I'm just making sure US. There we go. Square miles. Coordinate system, we want it to be the same as the current map, so our projected state plane of Arkansas. Add that in. And if we come over here, we see we get the same just about to it. It's a little different based on probably the statute versus survey miles, but we have 123. Oftentimes, depending on which one you're using, I've got 122 a couple times just based on changes in the area itself of Little Rock over the years and how they draw the boundaries. With that though, that's the number we need. So we see 123.55. We come back into CrimeStat. We're good to go there. And the next one is the length of the street network in miles. So if I come back into our ArcGIS, you can see below, I just moved it all the way over. You can see the base layer here has the street network in it. This is the full street center line. I have other ones that I've gone through and taken out roads that I can't geocode to, and I have videos on that. But for our purposes today, let's get into just the street original file. If we open this attribute table here, you can see this is what you would, the similar file, what you use to develop an address locator, geocode your data to, and you have a bunch of points to it. I'm seeing if at the end, if it has a shape style, it doesn't have a length to it. So what we're going to do, a bit different fashion. So we have 18,000 roads. We're going to add street length at the end. Keep this one as a double as well, because we want those decimal places. Hit save here. And when we hop back over into the full street center line, we're going to calculate this geometry. And truly, we want it to be length this time. So we keep it as length, and the units here we're going to do as, we can do US survey miles. Keep in mind, if we did feet, that's fine. You then just have to convert it to miles, because if you remember here, we do have the option of feet or miles. Thinking about citywide, is going to be more valuable to have it in miles versus feet, but there's 5,280 feet in a mile. So if we did this one in feet, we can always convert it that way, and it's not a huge ask. So if we do it, and I'll just walk you through that part then, just to show if you have it by feet, sometimes you want to know the average street length by feet. We'll go through that and we'll run some stats on that real quick. Current map is still going to be our projected one. Hit OK here, and it's going to calculate the length of every street segment that's in this centerline file. I also grabbed this centerline file from the GIS office, so we have a range of street lengths in here. With that, if we right click on it and hit statistics, it's going to pull up that information for us, so it makes it a bit easy here. So we can see that our average street length is just about 421 feet with a median at 317 feet. We can see our sum here is 7,860,535. So that's where I say if we want this in miles, I'm opening my calculator, we would take the 7,860,535.2 divided by 5280, and we see that we have 1,488 miles of roads in Little Rock based on this centerline file here. So I can take this number and input it here in terms of what's my length of my street network, 1488 point, I'm going to round 74. And we now have these basic parameters set up in terms of coverage area, type of distance measurement. There's plenty of research that looks at are there differences between direct or as the crow flies, your Manhattan or indirect or network distance. I'm going to keep it to our default here with Euclidean or direct distance itself. So we're good to go. We have everything we need set up to run some of our basic spatial descriptives. I will be the first one to say spatial descriptives do not get the same attention that other descriptives get in, I would say, normal research that is non-spatial. We get in the habit of seeing a mean, median, mode, standard deviation, our ranges, everything with that. But when it comes to spatial data, oftentimes we don't see really spatial descriptives at all. It's kind of glossed over. You see a count and some of the analysis you're running, but it doesn't get into detail into describing, especially the point level data of what you're looking at. I've tried to publish it a couple times and there's a lot of pushback against it. I think it's just a good way of introducing the data to understand it. And it's truly descriptive in nature. It allows you to talk about the general, be it distribution, whatever you want to look at here with it, that sets up your further analysis too. It's similar to other types of research that's non-spatial. You're still just describing your data, and I think that's glossed over a lot in our spatial research itself. With that, if we click on spatial description, we have different options on spatial distribution, your autocorrelation, which we'll get into, distance analysis, and you have a couple different ones within this. With that though, I just wanted to start off and get into your mean, center, and standard deviation, or standard distance with your standard deviational ellipse. Really cool. I've used this a lot over the years, especially when I was doing my master's thesis and even in my PhD. I thought these were pretty valuable tools to be familiar with. So to do that, we're truly just going to check these boxes here, and it's going to save the results for us. What you have to make sure to do is you have to save each individual result. So with that, I want to save my output. I want to save it as a shapefile so I can open it directly into ArcGIS. I'm going to specify a new folder that this will save into. Spatial. Let's see. We'll just label it spatial descriptives as a whole. And we're going to open this. This is going to be our mean, center, and standard distance. Save this here. We're okay with that one. And this one's going to be a shapefile as well. We're going to browse here. We're in our spatial descriptives, and this one's going to be our standard deviational ellipse. Hit save. Hit OK. So now we actually have set these up, and it will run this for us. So if you come down and hit compute, it's going to run this for you and actually spits out your information for you. So this is where you can save this to a text file. So we can see our standard deviation, our geometric mean, harmonic mean. And there's a lot of research out there, and you can even Google what these mean. But we'll get into the standard distance deviation, average density, and we'll get into different hotspots and how you want to define that, because it's, or operationalize and measure what's a cluster and what's not. But it is good information. This is the mean, center, and standard deviation. If we come over, we see our standard deviational ellipse, and we can see here what those look like as well in terms of our points itself. 2 times standard deviation is truly that 2 times. It's you're moving from 68 upwards from that. So with this though, you might wonder, well, shit, I have all this data, I've looked at it, this isn't great. I saved it as a shapefile, this is the text. Valuable information, I always recommend save it to text if you're not familiar with this or how to rerun it. You can just save it as a text file, and you truly just can open it in Excel. Anything else, it'd be mean, center, standard distance, text. It's already saving as a text field, so it's saved up there. We're good to go if we ever want to come back to it. For the purposes of why I save it as a shapefile, so we can actually pull this up in GIS. So with that, if I hop back over into Arc, I'm going to close out of my attribute tables and stats here. I'm going to turn off my street center line for now. But I can add these data that I just saved back into it. So it's going to bring up a standard deviational ellipse that represents where 68% of the crime is falling, the violence over the years here. So I'm in my example data folder, Spatial Descriptives, and it has a bunch of different options here. For our purposes though, I'm only interested in our standard deviational ellipse. This is the second one, so we'll pull that up here in a second. I'm also interested in our mean center. Oops, standard deviational ellipse, mean center. So here I'm just going to change what it looks like. In this ellipse here, this is where it's about 68% of the violence over 1999 through 2022 occurs. So if I turn on these points, we can see about 68% of that crime occurred within this ellipse. If you think about how we can select this and kind of check it, we have now an outline feature of that standard deviational ellipse. So I can do a select by location. If you just want to check this, so I want to select my violence, and let's do our historical that are within our standard deviational ellipse. And I'm just going to hit apply. So if we turn that on, you can see that I've selected a bunch here. Open the attribute table. And we have 27,000. So if I take the 27,379 divided by the 44821, 61% fall in there. So you're looking close to the 68. It's not quite what we expect, but with that, keep in mind, this is trying to grab as much as it can there. So we can see what that's trying to do in terms of talking about the directionality of this. Turn that off. And you can see here, this is the mean center, truly the point of the average of where all the crimes occur with the XY coordinates. That's all that's representing here. It doesn't give you a lot as much as the standard deviational ellipse. If you're familiar with the Centrographic Measures, and I'll link to an article by my prior mentor, James LeBeau, or Jim LeBeau. You don't hear about those as often anymore, but you can look at how the mean center changes or is pulled year from year to see the directionality. If you're familiar with the ellipse, you can look at the coefficients of circularity of the more rounded it is, the more concentrated it is, the more drawn out the ellipse is, the more stretched it is. So you have a greater amount of crime occurring in a larger area in the sense of being pulled in different directions. So there's a lot you can do in terms of describing even what this ellipse looks like, and I'll link to that article. You don't see about it as much in CrimCJ type of spatial work, but it is out there and just describing what that ellipse represents. And keep in mind, when you have this data here, we had our two standard deviational ellipse. So this is just grabbing more crime within that. So if I did my select by location here, and I want to do that same violence within our two standard deviation, hit apply, we highlight and open this attribute table. Which one did I just open? It doesn't look like I grabbed the right one. I grabbed the ellipse one. There we go. Open this attribute table. And we see that's probably close to 98. So if I do the calculator on this one, 43,822 divided by the 44,821. Yep, about 98% falls within that. And you can see the area is increasing as well. And you can calculate the area and everything with that, what it's representing. And you can cut it or clip it to the boundaries of Little Rock itself. So you can actually look at this a couple of different ways. I think the standard deviational ellipse is important to understand where a majority of your crime is occurring. If you're familiar with Little Rock, this isn't too shocking. It's actually kind of sad if you think about the history of Little Rock and how this interstate here was built to truly segregate the city as a whole. But these edges here, if you think back to the Branningham's work, is really trying to concentrate the violence in the city in these sub areas. So it's truly between the interstates itself. If you're familiar, this is kind of our white flight corridor area within Little Rock itself. And this is, if I zoom in, this is where I went to school down here at UALR. But some of our, oops, no, that was way off, up here. This is one of the most violent streets though, right here in the almost pretty close to the mean center, I imagine. Yep, there's the mean center. Of all of those years of crime, this is the highest street. If we look from 1999 through 2022, this street segment here has the most violence occur on it over that time span to it. I know that just because of the work that Nicole's done, but also I also lived up on Rosemont. So I'm very familiar with this area, but truly, if you think about edge effects and where a majority of crimes occurring, even historically, if you're familiar, and a lot of cities have this, if you're familiar with the urban design and how it developed, knowing I-630, how it was developed, 430 and then 30 here, it's truly boxing in our violence here. And if I turn this back on, we have a fair amount of crime that is occurring within this. We'll get into hotspot analysis here in the future and what constitute a hotspot, how many incidents and all that, the distance and with that and how you can play around with it. But this is a nice descriptive of 68% of your crime occurs here. And if we opened up this standard deviational ellipse, similar to how we did the area on the boundary itself, we can do the area of this standard deviational ellipse. So if I hit save here, we know it's a double, so I can calculate this area fairly quickly, and I'm not going to clip it because we saw it went into the river a little bit there. I'm going to do that as area, specify current map, units, I want it to be our square or miles again. Click OK. We're going to find that this is a smaller area that contains a majority of the crime. So if we think about how crime concentrates itself, not sure why it just messed up really bad right there. Let's see if it runs again. It's not liking the file type, so when in doubt, let's try exporting this. Where's it being saved to? Export, so spatial descriptives, standard deviational ellipse. We want area to it. Hit save, hit OK. So we're just exporting this as a new one. Nothing too crazy. I'm just wondering if it didn't like the original file type. So if we open this attribute table, let's try to do the geometry again for this one. So we have area set there. Let's do the area here. The unit itself is going to be our square US survey miles. Coordinate system, same as the current map, so it should be our projected system itself. My GIS is slowing down heavily. There we go, projected. Click OK. And it's still not liking to do that. It's asking for transformations, but it should be okay. Let's look at the properties of this: spatial extent, unknown coordinate system, and that is why. So it doesn't have the original coordinate system. So with that, if you're familiar with GIS and what we need to do, I need to project this data set back. So I'm going to project, I'm going to input the data set here. So I'm going to put in our standard deviation unknown coordinate system, and I'm going to save it as the current map. Nothing's going to change about it, but it's going to give it a coordinate system. Why doesn't it like this file? There we go. I'll specify that it is the same one, but it truly I am getting error after error with this. Of course, now it did calculate the area for us. Let's see if this one will now let me do the geometry. I'm wondering if it didn't like it because I still have CrimeStat open, which has been a while, but I don't remember that being a huge issue before, but it could be. And this time it ran fine. So even though I got the warnings, it still came up, so we're good to go. This still has our ellipse here. So if we think about it, 38 square miles. And if we think about it, so we have 38 divided by, we had about 123. It's about 31% of the area in Little Rock contains about 61% of all the violence from 1999 through 2022. So again, we're not getting into law of crime concentration. We're truly just talking about if you wanted to focus on an area that's seen generation year after year and decades worth of violence, We know this, and if you're from Little Rock, and a lot of cities have the same issue of you have generational, you can probably say where crime's occurring, and this speaks to that. So again, a couple of issues here at the end, pulling data back into it and trying to find the area, ended up working out even with the warnings. But that's a way to bring in your point data into CrimeStat itself. So your data setup, your primary file, using a point file, setting up your reference and measurement parameters. This will be important as we get going into some other modeling itself, spatial analysis itself. So get in the habit of just checking these. We'll get into some of the time units. I haven't done as much of the time stuff in CrimeStat itself. I'll be the first one to admit that. So it might take some poking around for myself to get into it. But with that, we got into our spatial descriptives here with a standard deviational ellipse and our mean center. Convex hull, if you think about it, if you're not familiar with that is, it just is your straight line. An ellipse is trying to grab it, represent it. We'll get into convex hulls when it comes to hotspots and kind of the outermost points. It draws a boundary around those. It can change the area. I use that heavily with some of the hotspot stuff. That was just comparing different ones. But we'll get into playing around with some of these different tools itself. With that, this is a long enough video as is, but it does cover how to import a file, bring it back into GIS and look at it and represent it. So if you have any questions, feel free to reach out. If I mess something up terribly wrong, please let me know as I delve into more of these CrimeStat videos. Until next time, take care.